Hey everybody, and welcome back to another fun and exciting pre-algebra class. Today's lesson will be in 1.12, that is on page number 52. On page number 52, we're going to find the application of percents. Now you might say, what do you mean by application of percents? Well, when you apply something, you're taking something that you've learned and you're using it like in real life. So I've told you as we've been going through these things that we will be using this stuff in life. So this lesson is kind of, I know I'm going to say the word, it's a lot of story problems, a lot of word problems. I'm sorry. I know you hate those, but that's what math is. Math is applying what you've learned to real life situations. It's using logic and problem solving skills and all these other things. So the numbers, I mean, they're important. You want to get the numbers right. But what's really important is that process, right? Making sure that you know how to do something, making sure that you know the steps in order to be able to solve something, making sure that you can use your mind, logic, problem solve. That's really what math is all about. So in order to work on that, we need to work on these story problems, these word problems. So 1.12, the application of percent. Let's learn how to apply what we've already learned about percents. So percent of change, what is it? It is the amount of change in a number, whether it be up or down. We're just looking for the percent of change. So how do we do that? How do we accomplish that? It's actually fairly simple. It's just 3 easy steps. Number 1, find the amount of change by subtracting the two totals. This will make sense to you in just a second. Number 2, divide the amount of change by the original value. And number 3, we're going to express our answer as a percent by moving the decimal 2 places to the left. All right, so let's actually do one. And I did say, before we do one, let me talk about one other thing. Increase and decrease. What does that mean? Decrease is when the total goes down. It decreases. Increase is when the total goes up. So if I go from 50 to 70, I have an increase. If I go from 50 to 30, I have a decrease. Okay. So let's do this one. This one is actually an example in your book if you're following along there. What is the percent of change if it was 64 degrees on Wednesday and 60 degrees on Thursday? So what happened? Well, it was 64 degrees and it went to 60 degrees. So was that an increase or a decrease? That's right, we're going down. We went from 64 to 60, so we're going down. We're decreasing, okay? So how do we do this? Well, let's go back up here. Find the amount of change by subtracting the two totals. Well, I can subtract. Hopefully you can subtract too. So what do we have? We have 64 and 60, so we're going to subtract those two totals. 64 minus 60 equals 4, okay? Some of you did that in your head. You're smarter than me. I had to do it on paper. No, I'm just kidding, but I did it on paper so you could see it. Step number 2, divide the amount of change by the original value. All right, well, that one might be a little bit harder, but not too bad. What is the original value? Okay, now that's an important thing for us to understand. So let's go back up here to this main paragraph or this main sentence here. What is the percent change if it were 64 on Wednesday and 60 degrees on Thursday? Well, Wednesday comes before Thursday, right? So what's the original total? The original total is 64. That's what we started with. Wednesday, it was 64. Okay? So here's what we want to do. Divide the amount of change by the original value. What's the amount of change? This is the amount of change. Okay? The amount of change is 4. So we're going to divide, look what it says, divide the amount of change by the original value. So we're going to do the amount of change by the original value. What's the original value? The 64. Okay. And you say, I can't divide that. Yes, you can. put a decimal, and add some zeros. Okay? How many zeros do you add? I don't know. How many do you want to add? You're going to need to add at least 2 probably, and usually we're going to start with 3, but we'll see. We'll see how many we need. We don't know yet because we haven't started dividing. Well, one way to divide this, and this is the way I like to do it, is 6 goes into 40 how many times. We're doing what's called estimation. We're kind of guessing at this thing. So 6 goes into 40 how many times? Well, 6 goes into 6, 36. So let's try 6. All right. So 6 times 4, 24, 36. Whoops, I should put that 4. My bad. That 4 goes over here. All right. So 24. 6 goes into 6. 36 plus 2 is 38. There we go. That looks better. And we're going to subtract. And we're going to get 6. And we're going to get 1. And we're going to get 0. All right. So we're good. We compare. 16 is less than 64. Good. We're going to bring down. And so now we're back to the drawing board here. We're trying to figure out how many times this goes in there. So now we would say 6 goes into 16 how many times? Well, 6 goes into 16 twice, really. So we'll try 2 here. Don't forget there's a decimal here. I forgot about that decimal. That decimal goes up, straight up. Okay? 2 times 4 is 8. 2 times is 12. And so we're going to subtract, and we're going to get 32. Okay. We can add another 0. Actually, we're going to need one here because if we're going to round off, we're going to need one more 0. So that goes there, and that's a 0. And so now we say 6 goes into 32 how many times? Well, it goes about 5 times. So let's try 5. 5 times 4 is 20. 5 times 30, 32. Oh, look, we got it. It came out without a remainder. Good. So this is our answer. Not quite. Not quite. We have one more step. Let's go back to our step. Express your answer as a percent by moving the decimal 2 places to the left. 1, 2, 62.5% is our answer. Percent sign got a little weird on me there. So there we go. All right. 62.5% is our answer. And that is the percent of change. Now, let's go. Was it a percent change up or a percent change down? Okay. And the answer would be that it was a percent change. I just noticed something. I did this wrong. I'm sorry, I did my math wrong. It's actually right, but it's wrong. I put my decimal in the wrong place. I actually did this wrong. That 6 should be moved over 1. This whole thing should move over 1. At that. And the 6 should be here. There should be a 0 here. I didn't put my space holder. All right. And so that was 2, 5. So I messed up. So 2 spots gives me 6 because I was looking at that going, that is too much of a percent change. That is 6.25% change instead of 62.5. So sorry about that. That's my bad. I make mistakes too, and it's okay. Because we learn from our mistakes. So hopefully I won't make that mistake again. All right, the next section is on discount, rate of discount, sale price, and all that good stuff. Let's look there. You can look in your book or you can look here on the screen. What is a discount? A discount is when you go to the store and they give you a better price, right? You get a discounted rate. You get 30% off. You get 20% off, all right? So you're getting a better deal. That's a discount. It's a percentage off the original price, so you're getting a deal. What's the rate of discount? Well, the rate of discount is the percent the item is being discounted. So 25%. 50%, 10%. That's your rate of discount. These are just vocabulary words so that you can understand what I'm saying when I say it. What is the sale price? The sale price is the price that you are going to pay. Okay, so you take the original price minus a discount, and that's going to be your sale price. Okay, and so let's look at a problem here. We're going to find the sale price of a $700 TV that is 25% off. So let's talk about it. What is our discount? Well, we don't know our discount yet. That's what we're looking for. What is the rate of discount? 25%. What is the sale price? Well, we don't know that yet either. The only thing that we know is the original price. Okay? So we have the original price and we have the rate of discount. Well, this is kind of an easy problem. All we have to do is take 700 times 0.25 for 25%. We move the decimal 2 places. So we just do that. 0, 0, 35. 0, 0, 0, 14, and we get 0, 0, 5, 7, 1. So the discount on this thing is $175. That is the discount. What's the discount? That's the percentage off. Now, how are we going to find the sale price? Look, we take the original price minus the discount. All right. So let's take the original price, $700. 700 minus 175, and we will get, we have to pay $525. That's how much we have to pay. So what is that called? That's called the sale price. That's the price of the item that is on sale. Okay? One more thing, and then we'll be done. When we have more or less in percents, what does that mean? Well, sometimes you can have more than you have, or you have less. What we really did right there was a less than in percent, because it was 25% less than 700. But sometimes you could have more than. And we're not talking about sales prices anymore, because sales are always less than, right? A markup would be more than, but typically you have sale prices that you're worried about, not the markup. So more or less than in percent. Multiply the percent times the original value, and then add or subtract your product. So this is basically what we just did, but now maybe we're going to add. When will we add? We'll add when it's going up. We'll subtract when it's coming down. All right, so let's look at this problem. If a company started with 50 employees, so that's the original number, and now they have 20% more employees, so there's 20% increase. We're going up. Okay, so how do we do it? Well, we just multiply 50 times 20%. So 50 times 0.20. I'll write it like that. It's easier to do it that way. Some of you don't know how to multiply like that, but it's easier when you have a 0 to offset the 0. So then 2 times 0 and then 2 times 5 is 10, 2 decimal places. So we have 10 new employees. Okay. And now the second step to this was to add or subtract. Well, when you're adding, that means that you have a increase. And when you are, whoops, I did that wrong. When you're adding, there we go, you have an increase. When you're subtracting, you have a decrease. All right, so we're adding, so we're increasing. So we're going to take that 10, and we're going to take 50 employees, because that's our original number. And we're going to add 10. How many employees do we now have? We now have 60 employees. So a lot of times all this is adding or subtracting once you get to the end of it. But usually it's 2 steps. So you have to multiply and then add or subtract to get the answer on these ones. All right, hope you learned something there. Lots to think about when we're applying percent and how to use percents to real world problems, things that actually happen in the world that we live in. So just keep working hard on these, do these practice problems. And here's what I always tell students with word problems when on the practice problems. You've got to do something. You've got to put something down on the paper. Don't come and say, I don't know, I don't understand, I don't get it. Okay, well, you're not trying. Okay, you're not applying yourself. So on these word problems, write something down. Try to figure something out. Do some math, right? And then you can figure out, maybe you didn't understand it, and it's okay. But then you can figure out, where did I go wrong? What did I miss? And then you can learn from the mistakes that you made. That's the best way to handle word problems. Make sure that you're writing something down. Make sure you're putting forth some sort of an effort. All right, that's all I've got for you. Hope you learned something there. You have a good one. We'll see you later. Bye-bye.